Now this illustration deals with isolation of objectionable direct current from grounded currents that may be fed like from a DC battery source or a little distribution transformer or whatever. But mainly, sometimes, say a piping system, a vessel, is fed with DC, so a battery effect would not occur over the cables and stuff that provide a condition of installation where corrosion won't set in. Now in this illustration, we're seeing a fused primary of a distribution transformer supplying service entrance. And notice we have two driven rods, one for the primary side, one for the secondary side, because we have an arrestor listed there. On the primary, we have the primary voltage coming in, and we have the grounded leg neutral that's connected to earth ground. Then on the secondary side, we have the grounding point of the grounded conductors you see in the illustration, feeding into the service equipment. Now, notice at the very bottom there, we have a DC isolator, AC coupler, a PCR is abbreviated, motor-operated valve in the gas pipeline, providing a DC power, but it's grounded in such a manner that it doesn't set up a battery effect between the two where corrosion would set in. It helps prevent this condition becoming a major problem. And that's what this illustration 16-11 is showing. It is showing the utility transformer, wherever that may be, on a pole, wherever. It's supplying the service equipment. And from there, we are setting up a DC source that will prevent corrosion of a gas pipeline, say, as shown in the illustration. Now, we'll get into more of this as we get into different chapters of the Stallcup's electrical design book. But this figure 16-11 is showing isolation of objectionable DC current on a ground type current system in accordance with 250.6E, where this device is manufactured especially for this purpose, where we do not do some illegal grounding, not realizing it. This gives us a diagram coming from the manufacturer with the equipment, so we connect it in such a manner to prevent this problem.